Hi guys, welcome back. So in this video we're going to see exploitation techniques. So we have already completed 4 chapters. So if you guys missed these previous chapters, please go and watch to get better understand. Okay, so let's start from client-side attack. So first we'll start from client-side attacks. Client-side attacks vectors are especially insidious as they exploit weaknesses in client software such as browser as opposed to exploiting server software. So this often involves some form of user interactions and deceptions in order for the client software to execute malicious code. These attack vectors are particularly appealing for an attacker because they don't require direct or routable access to the victim's machine. For example, imagine that an employee inside a non-routable internal network has received an email with an attachment or a link to a malicious website. If the employee opens the attachment or clicks on the link, the content, which may be a document or the content of a web page, is sent as input to a local application on the machines. The application will then render that input and could execute malicious code. The employer's machines would then be exploiting, perhaps launching a remote shell from the compromised machines out through the firewall to a listener on the attacker machines. In this chapter, we will describe some of the factors that are important to consider in the type of attacks and walk through exploitation scenario involving both malicious HTML applications and Microsoft Word documents. Know your target. From an attacker standpoint, the primary difficulty with the client-side attacks lies in the enumerations of the victim's client software. So the secret to success in client-side attack is, as with most things related to penetration testing, accurate and thorough information gathering. We can use both passive and active information gathering technique against our client-side attack targets. For example, in a recent engagement, we were tasked with attempting to compromise corporate employee with the client-side attack and various phishing techniques. However, we were not allowed to make phone contact with employees. Given that restrictions, we Googled for various known external corporate IP addresses and found one on a site that hosts collected user agent data from various affiliated sites. So this information is similar to site information. Let me show you this. So on the Netcraft websites, one of the best tool. So any website. So just click the lookup informations. So you guys can see that the OS operating system, so what operating system they are using, the IP address. So we already discussed these informations. Okay. So you guys can see more informations. There's a passive information gathering, active client information gathering. By contrast, active client information gathering techniques make direct contact with the target machine or its users. So this could involve placing a phone call to a user in an attempt to extract useful information or sending a targeted email to the victim hoping for a click on a link that will enumerate the target operating system versions, operating system versions and browser versions and installed extensions. So we will explore active information gathering techniques in the videos later. Okay, so now Social engineering and client-side attacks. As most client-side attacks require some form of interactions with the target, such as requiring the target to click on a link, open an email, run on attachment, or open a document, we should primitively leverage social engineering tactics to improve our chances of success. Imagine the scenario: we are on engagement trying to execute a client-side attack against the human resource department. We could just blindly jump in and attack, but our chances of success are slim, since we have no idea which operating systems and application they are using, nor which version. Instead, we will favor caution and respond to a job posting with a malformed resume document that is designed to not open. The next day, we receive an email response indicating that, not surprisingly, HR cannot open our document. In an attempt to help resolve the issue, we respond asking what exact version of Microsoft they are using, suggesting that the issue may be caused by a version incompatible. In our scenario, we discovered that the HR representative is unsurprisingly using a specific version of Microsoft Office, and they are allowed to execute Word macros. Armed with this information, we can craft a second resume Word document containing a Mac leverage PowerShell to open a reverse shell and email it to them. Of course, this is a simplified success story. Your social engineering pretext will most certainly have to be more intricate and specific based on information you have gathered in advance. Client fingerprinting. The process of the client fingerprinting is extremely critical to the success of our attack. But to obtain the most precise information, we must often gather it from the target machines itself. Let's assume we are convinced our victim to visit our malicious web page in a practical example. So our goal will be to identify the victim's web browser versions and gather information about the underlying operating system. We could create our own custom tool, but there are many available open source fingerprinting projects. The most reliable are generally those that directly leverage common client-side components such as JavaScript. For this example, we'll use the Fingerprint JS2 JavaScript library, which can be installed by downloading and extracting the project archive from its GitHub repository.
Okay, let's see some practical exercise. For that, we are going to use WebGoat. WebGoat is a pretty good project that is maintained by the Open Web Application Security Project, or OWASP. So you can Google it, OWASP WebGoat, so you guys can find the information, more information how to install the WebGoat. So this is a very useful tool. So WebGoat is a deliberately insecure application that allow interested developers just like you to test vulnerabilities commonly found in Java-based applications that use common and popular open source tools. So you guys can find the information here. So how to install, on your Linux machines or Windows machines. This information is for Linux machines, but you guys can Google it how to install it on your Windows machines. I'm using a Kali Linux machines and Ubuntu, so I installed this package on my Kali machines. Okay, so let's you need to run. So you need to run this first. Just copy the. So you need to once you have installed this code on your Linux machines, you need to run. You can either use the local host, or you can use the IP address, a local IP address and the port number. So I'm using a default one, so 800, and then this is a local machine IP address. So I need to click enter and then go to the browser. Okay, so now, so you can use the local IP address and the port number, and then this is a case sensitive web code. So you can just enter the same URL on your browser. So you have to register first, but I have already registered. So I'm going to so it's logged in successfully. So you guys can see the topics, the practice labs. So it is helpful to have a place where you can practice web application attacks. WebGoat happens to be one of them. So there are several places where you can get damaged sites that you can use. So Foundstone, for example, used to have several Microsoft First website, and I believe they still do. So one of them was called Hack Me Bank as an example. HACME Bank as an example of it. Here is one though called Damn Vulnerable Web Applications, and you could download this, install it on your web server. Then you log in, gives you some place where you can perform some attacks. Now there are instructions here. It tells you, leave it. Okay, you guys can see here. So now let's see XSS first, cross-site scripting. So normally the cross-site scripting is a web security vulnerability that allow an attacker to compromise the interaction that users have with the vulnerable applications. It allows an attacker to circumvent the same origin policy, which is designed to segregate different websites from each other. Cross-site scripting vulnerabilities normally allow an attacker to masquerade as a victim users to carry out any actions that the user is able to perform and to access any of the user's data. If the victim user has a privileged access within the applications, then attacker might be able to gain full control over all application functionality and data. So there are three main types of cross-site scripting attacks. So first is reflected XSS injections, where the malicious script comes from the current HTTP request. And then second one is stored XSS injections, where the malicious scripts comes from the website database. Okay. And the third one is DOM-based XSS, where the vulnerability exists in client-side code rather than server-side code. So we will see these one by one. Okay. So this is the practical exercise page. So this is very simple one. You can just copy and paste it here and then submit. You will get that answer. Of course, here they actually go over many different exercises and many different explanation of what cross-site scripting is, right? For example, so in this case, we have a note that many modern web browsing, including Chrome and Firefox, already filtered out, and then in this case, we have noted that many modern web browsers, including Chrome and Firefox, already filtered out and banned different JavaScript from the URL or the that URL for actually from input in many different things like forms and hidden fields and many other right now. Let's take a look at one that is a little bit more interesting, right? So in this one, 7, okay, it says identify which field is susceptible to accesses, right? And then you have different field here. You guys can see here the different field, and then here you can see that input. You have a enter some input. Here you can see that enter your credit card number. So here what we are going to do is, here you guys can see enter your credit card number. So here we are going to just enter it. You can either copy this field and then modify, or else you can type it manually. Script. This is a message, and then you close the script. Then just enter. Here you guys can see here the message. So then now you can see already know the credit card number field was susceptible to it. So now you can see the pop-up window right here and nothing was right. So you're actually able to manipulate the application, at least verify that you have the cross-site scripting condition right. But is this saying here, well done, but alerts are not very impressive? So are they saying right here, so please continue? So what we can probably do is, after that, is identify a potential term-based cross-site scripting. So here you guys can see here, so your objective is to find the route and exploit it. First though, what is a base route? As an example, look at the URL for the lesson. So this is a URL. It should look something like WebGoat start.mvc and lesson cross-site scripting lesson 9. So you guys can see here from beginning of start.mvc until 9. So the base route in the case is start MVC lesson. So here you guys can see here, right? So and then the cross-site scripting lesson 9, after that there are parameters that are processed by the JavaScript. So this is a parameter. So highlighted one, okay. And then the first thing is, so what is a route for the test code and state in the app during production? To answer this question, you have to check the JavaScript source. So what we can do is just right click on the page, the Firefox browser, inspect elements. So we need to locate the router, get router. Okay, for that, the developer mode, you have to click debugger. So you can see there is a number of JavaScript here. Just scroll down a little bit. View. Scroll down. So you guys can see here the code router. Right. So just double click. So the question here is, what is the route for the test code that stay in the app during production? You have to check the JavaScript source. So just press Ctrl M. Routers. So here you guys can see here the routers. house, and then the parameter, right? So here you see the start, and then .mec hash test /. So here you guys can see the test. So this is a test route. Okay, the test code does stay in the app during production. Sorry. So let's do this. So now you can see. So you can see this correct information. So just moving on the next exercise, 11. Sorry, the page. Here you can see that some attacks are flying. Fortunately, you have the server running here, so you will be able to tell if you are a successful user route you just found, and see if you can use the fact that it reflects a parameter from that route without encoding to execute an internal function in WebGoat. So the function you want to execute is, so let's copy this, or else you can type it manually. Sure, you could just use console debug to trigger it, but we need to trigger it via URLs in a new tab. So this is a URL. So what we can do is just right click on the tab, duplicate tab. Here we can use the base row. So what we saw before, let's remove it. Test. So here we can just copy this and then paste here. Go. Yes. And close it using the applications. There's a tons of applications, so I'm using this one. Just make sure everything is okay. So webgo.custom.js.phone home. Okay, that's great. So this is the base route. What we saw in previous exercise. Just enter. You guys can see here there's a small this is for a moment. So I need to open this script. So now you guys can see here the base route message, the confirmation list. So just right click and go to inspect elements. So we can now locate the number. So the phone home response is. So you guys can see here. Just copy this. Click. And then go to the tab. Testing. Sorry for that. Correct. Sorry, I need to enter the. Okay. So I just missed the icon. Here you guys can see here. There's. I need to copy the whole thing. So you can see here the I hope you didn't change or use the console. So you guys can also try out that another OWASP project called Mutillidae. You can also use that project for top 10 web vulnerabilities. You guys can get downloaded from website. So you guys can find more information on them. You guys can get download from here. the source version. So and then the installations, everything you guys can find YouTube, So as I said before, there are several forms of cross-site scripting. So with these tools, we are going to see, we'll examine reflected cross-site scripting. Okay. So now we can open cross-site script, reflector, and then just try to find, scroll down, password generator, this topic. So here what we are going to do is we're going to change the username parameter from anonymous to QWERTY. Then press enter. So the value of username gets reflected back to us inside the web page. So you guys can see here. So last time it was anonymous. So now it has changed QWERTY. Okay. However, it is important to understand the context of where it is getting injected. That is our value being placed into HTML context, or is being used as an HTML tag attribute, or maybe it is being placed into an existing scripts tag. We need to inject JavaScript that will get execute from the context that it is in, meaning that we may need to add data, terminate an existing tag, or start a new script tag. Okay, for that we can just right click the page here, just right click, view page source. Okay, so you can now press Ctrl F to find the word QWERTY. So you can see that it should be fine. Okay, so here you guys can see. So we provided as shown in the screenshot. On this page. So we have now managed to find this password. It appears that the context for the injection is not regular HTML but an existing piece of JavaScript. So we will need to formulate our injected code to the close of the first statement that sets the inner HTML for the ID username input element. You guys can see here. Okay, so then execute what we want, then begin another statement that incorporate the final value. You guys can see here the double quotations. Okay, so that they are not out of place and causes syntax error. So based on what we just saw, we will use the following. So let's try to find another one. So based on what we saw, what we can do, we can just modify this script. Okay. So this meet our requirement that we outlined in the previous step. So it will continue to set the HTML element to the this password is QWERTY. So it will continue to set the HTML element to the example this password, as you guys can see here. So it will continue to set that the HTML element to this password is QWERTY. So it will then execute our malicious JavaScript code. It then start a variable declaration for a variable that likely doesn't exist on the page. So the variable declaration doesn't complete as the existing code that our username will placed into will complete the statement. So you guys can see here. So this meets our requirement that we outlined in the previous steps. It will continue to set the HTML element to this password is this password property. As we seen before in the page, it will then execute our malicious JavaScript. It then start a variable declaration for a variable that likely doesn't exist on the page. The variable declaration doesn't complete as this existing code that our username will be placed into will complete the statement. Okay, we will now see exploit persistent cross-site scripting. We viewed an example of reflected access. I hope you guys can understand. This attack is okay. We will see now exploit persistent cross-site scripting. So previously we viewed an example of reflected cross-site scripting. So this attack is familiar in nature. Once the malicious link is gone, the attack is gone as well. Persistent cross-site scripting is a more permanent type of attack. In this case, the malicious JavaScript is injected in some parameter that gets stored somewhere, often in a database. So this value is then used to render the page to all clients. That means that anyone who navigates to the page will be attacked. A common example is web form. If a user can post JavaScript, then anyone who views that malicious forum post from the time of attack until the post is removed will have the code run in the browser. So now we will see more fully simulated multiple parties, both the attacker and the victim. First, we will create the victim account in Chrome. Next, we will create the attacker account in the Firefox and launch the attacker. Then, in Chrome, the victim will view the malicious content. Then back in Chrome, the attacker will see the result of attacks. Okay. So we can now click the login and register. So here click the please register link. So now we can create the victim user by entering victim in all field. Okay. Okay. So then click create. So we can now click the login page again. So we can now enter the victim and then victim and click login. So you should now be authenticated as a victim user. Okay. So now you can open the Chrome browser, another browser. Sorry, Firefox. You can now open the Firefox browser. So previously we used the Chrome. So now we open that Firefox. So now we are doing the same steps on Firefox. Now we can enter the attacker in all field. So now go to login again. Login as attacker. attacker click login. So you now managed to log in using the attacker username and password. So now we can go to the we can now navigate to the 2017 project, what we are working right now. Then cross-site scripting. Here you can see the persistent second row, right? So now we're going to add to your doc. So we can now going to create the small script. Sorry, not this. This is a simple script for practice. So we have now completed the script. So we can now just make sure everything's right. So that is something cool. Okay. Now click the save block entry. So the malicious code we injected will make a request to address we specified, namely HTTP localhost 444. So it is a port code. In a regular attacking situation, the localhost would be replaced with the attacker's IP address or domain name. The 4444 indicates the port number where the call will be made in order to receive the data. We need to set up a process to listen. What we did earlier now using the netcat. Okay, so now we can just open terminal. So here we can just enter netcat command and see -lep 4444. So it's now the listening is started. Now switch back to the Chrome browser. So as we simulate the victim browsing the stack. So now we can open the view box. So for that, go to the cross-site scripting and then persistence, second tab. Now we can see the view someone's. Okay, so you can see in the place where you please choose author, right? You can just drop down and then go to attacker. Okay, just select attacker. So we can now click view log entries. So the log entry that states hi from attacker. Okay, it's visible now. Now switch back to the terminal window. Let's minimize. So that netcat listener. So this should be bunch of data there. The most interesting part is the portion of the URL after. Okay, let's move on another topic. SQL injection flaws. An SQL injection is the process of injecting unauthorized characters into SQL query statement in order to alter a response. In this exercise, we will see three phases of security: exploitation, analysis, and mitigations in order to get a better understanding of why SQL injection occurs and how they can potentially be stopped. We will see specifically how to perform a SQL password bypass attack. So by doing so, you will also get an understanding of why it happens and how it mitigated. So this is a lab setup for injections, SQL injection flaws. Okay, so we are going to use the Kali Linux machines and then Ubuntu machines and the web servers. Okay, first let's start. Let's begin from Ubuntu. Let's open the Ubuntu machine. So here, first open the ut.c. So here we can open SSH your bank.com session link, so which we already created for testing purpose. So then you can now enter the password for the script. So and then now we are going to enter the lab script. Okay, now the script. So we have to wait for the task to finish running and examine the output. Okay. So it's still running, and then it's almost completed. So we have now managed to run the script, and then so to set up the login page, for testing purpose. So we can now open the Kali Linux machines. So now we can run the browser. So now let's try open that back. So here, as I showed before, so let me open again. So you guys can see here the Ubuntu machine. So we have run the script here. So now we are going to bypass the password here. Nice. And then, so you guys can see here, login successful. So in this exercise, we are going to enable feature in MySQL that is known as the general log. When enabled, MySQL will send a copy of all the queries received by the database to that file, where this statement can be analyzed to help pinpoint the vulnerability. Okay. So let's minimize this and then open the terminal. We can now use SSH to log in backend web server. And then now we can enter this command. the password. So we can now use the command show variables. So we can enter this query to view the listed rows, 26 rows in set. So we can just specify using the command. So general, then percentage, and then okay. So now we can enter. So we can now see the general log as it shows up, right? And then you guys can see here the general log file. Okay. So now let's do some modify. So if you want to enable, you need to add, you need to set, use this command to set. So execute the SQL statement to enable the general log. For that, do that, and then general one. Okay. So when you enter 1, which means it's enabled. So now it's enabled successfully. So let's re-execute the same SQL statement. So now you guys can see here on. So before that it was off. Service now is on. So now we can quit. Reverse slash and quit. Just minimize this one. Now let's open the browser again. So now we can enter the same, we can visit the same web page, the testing page. So we can now enter the collimation username. And then so now you guys can see here the login successfully. So we can now go to the terminal, just minimize this one, go back to that terminal again, and then we can use the sudo a okay. So now let's enter. You guys can, you need to enter the password. Okay. There is I put in my password. Sorry. Okay. Now you guys can see the password that we entered here in the browser. So you guys can see the password here in the log, web.logs. Okay. So this is one of the easy method, and then we can now. So if you guys want to see the alias, the open door machine, so you can also test. So just enter here. So in these times we don't enter the password, right? So we just bypass the password. So if you guys enter the same query again. So now you guys can see only the username, not password. Just bypass the password. Okay. So last time we used the password, so that's why it's visible in the web.logs. So now it's not visible. So just make sure. Okay, now we can see that attack mitigations. Up until this point, we learned that PHP works in coordination with the HTTP post method to retrieve data from the login form and store the result inside variables on the server side. The data inside this variable is not properly escaped, which alters the PHP query statements resulting in SQL injection. In this exercise, we will take a look at a process that is known as escaping, which uses PHP functions called mysql _real _escape _string, something like that, that can be used to mitigate the attack. Okay, so now let's clear first. So we can now go to that login page PHP and the same color Linux machine, so we can do this. What we can do now here, we can just we can just remove the /. So as I said before, this is a PHP function what we are going to use it for attack mitigation. Okay, now after remove the /, we can now save it. Press Ctrl S and then N. So we can now open the browser again. So just remove this. So go to the same main page, the login page. Enter the same command, same query. Now you guys can see this message that we can verify the attack is no longer successful. So that's it guys for this video. So we will see more topic on next upcoming video.
Please subscribe my channel, press the bell button to get more update, share the video to your friends guys. See you, bye bye.